with Chennai
23,800.
23,000. Yes, yes. 23,000. That range is okay. Exact answer we will discuss in the coming class. Now we will
Okay,
go
sir.
to what is called measurement. Okay, measurement means the last class we have estimated. Estimated means what is the difference between estimation and measurement? Solar radiation we can estimate as well as measure on the Earth's surface. Estimation means using some theoretical relations derived by some people, Page Angstrom, like that a relation we can use to get the energy. Okay, kilojoule per meter square per day, like that. Measurement means we will use some instruments, like you are measuring your current voltage, etc., using voltmeter, ammeter. We can have instruments. Okay, many instruments are there. Some typical instruments are pyrheliometer, pyranometer, shaded ring pyranometer. So beam radiation, direct beam radiation means we can use pyrheliometer. I have introduced this one last class. Then pyranometer means global radiation. Okay, global radiation. Diffuse radiation means shaded ring pyranometer. So if you are in the campus, you could have done some experiments. This is these are all the instruments. In our laboratory also it is there. Pyranometer. What is the working principle? Working principle, anybody? This will be having a sensor. Okay, this black item is a sensor. So in a pyranometer, it is exposed to ambient, or in the sense solar radiation. Suppose here the sun is there. The solar radiation, all sort of solar radiation. That means beam radiation also can come and hit it. Any diffuse radiation, that means other than direct radiation, that can also and come hit here. So this in the actual thing, in the top one you can see a sensor, no? This is the sensor. So this sensor is exposed to both the beam and as well as diffuse radiation. That means global radiation. So it will measure global radiation. How it is measuring global radiation? It will have a sensor. That sensor is typically thermopile. Thermopile means by Peltier effect you will have a EMF. So when solar radiation is hitting here, what will happen? This black sensor will absorb radiation and it will get heated up. So the thermopile hot junction, one junction is getting heated up, the another one will be the other side. Okay, so this is the what is written here, electrode. Okay, electrode means thermopile electrode. One hot junction here, other one is not exposed, so it will be cold. Okay, here this will be hot. So by Peltier effect we will get an EMF. EMF will be very minute, 0 to 10 millivolt. That is the range, typical range. Okay, you can expect very little EMF generated, that you can measure using, this will have a wire code. Okay, you will get a EMF that you can connect it to a voltmeter. So you will read the millivolt generator. So how to get our solar radiation? We are getting millivolt. So you can get a watt per meter square. This millivolt converted into. So a correction sensitivity will be there. Okay, the manufacturer of this instrument will give you a sensitivity. What is sensitivity? You can see this is the actual one in our laboratory. Type SR11. Serial number is there. Make is there. Sensitivity is given 19.22 millivolt per watt per meter square. Right. Are you seeing this one? 19.22 millivolt per watt per meter square, right? So 1 watt per meter square correspond to 19.22. If you are getting some other value, you will get a calibration equation. So that calibration equation you can use to get this final output, watt per meter square. Okay, equation. So that is how we can get solar radiation measured using a pyranometer. So if you are asked, you can draw this figure. It will have a stand, case, sensing area. Then top you will get two glass cover. Why it is? What is the need of this two glass cover? To protect this sensor from any ambient disturbances. Okay, so it is clear glass with the maximum optical characteristics. Okay, transmittivity etc. very good. So that we are getting the thing. So the this construction is having a adjustable leg. Okay, housing, adjustable leg, etc. for proper placing of the instrument. Is it clear? Is it's working? Yes or no? Pyranometer. Akshad Bisht.
Yes, sir.
Working is clear or not?
Yes, sir.
Okay, so this is global radiation. Next we can have pyranometer. What is pyrheliometer? What is pyrheliometer? To measure beam radiation. Okay, so it is like a pipe. So the sensing area will be at the bottom side, not on the top. In the pyranometer, sensing area is top. Suppose this is the sun. We can align this tube in line with the sun. So only the beam radiation will come and pass through the tubes and hit the sensing area. So this thermopile, you can see here, thermopile is at bottom. So thermopile, same principle, EMF will be generated. So the exposed area will be hot junction. The unexposed area will be cold junction. So in a thermopile, if we make hot and cold junctions, by the property of the thermopile, it will generate EMF. So very little EMF that you can again calibrate to get a watt per meter square. Okay, one sensitivity will be given by the manufacturer. You can get an equation of this thing. Okay, instrument. So it is having a window, a tube, thermopile sensor, and a tracking mechanism. So we always want this instrument to align to sun. So it will have an adjustable screw stand. We can align in two axes, horizontally as well as vertically, to align to the exact line of the sun. So this is the one looking like this. We also have the same instrument in our laboratory. So pyranometer. You can write in your own words with the suitable diagram what is the working of these instruments. Another one is this is the actual one in our laboratory. Okay, you can see this wire is there to connect it to voltmeter. You can measure the millivolt generated, that will be converted into watt per meter square by considering the sensitivity of this instrument. For this instrument, 19.22 watt milliwatt per watt per meter square. That is the sensitivity. Now diffuse radiation only you are interested means you can make a shading in the pyranometer. So that is called a shaded ring pyranometer. So this is the shaded ring. Okay, this black circular object is called shaded ring. This will make a shading. So suppose sun is here, beam radiation will be shaded. It will not get a hit here. So whatever radiation coming and hitting here will be from the side. That means diffuse radiation. So it will measure only the diffuse radiation. So working principle everything same as pyranometer, but we are allowing only diffuse radiation, not the beam radiation. So it will measure only diffuse radiation. Okay, is it clear? It will also have all the hardware and the working principle. This is a page from one of the laboratory record. You can see in Vellore we have a instrument global radiation measured. So these are all the millivolt. Here you can see millivolt, global radiation, diffuse radiation, beam radiation. Three type of radiation. What are all the millivolt generated by the instrument? So by using the equation of conversion, people have found out the watt per meter square. So this is global means 873, 835 I think. Okay, very small only. 835 it is getting. Diffuse means 244 getting. Beam means the difference. 8 global minus diffuse is beam. Okay. So this is the typical range 873. Diffuse means 200 range you can expect. Beam radiation means 600 range you can expect in a sunny day. So this one is a solar panel assembled in our building. GDN, VAT, almost all building top we have solar panels installed. This is in the GDN block. So I have given a case assignment for you to make a case study of some solar installations. So I think many people have taken case study from internet. You could go and visit some places. If time permits, still you can do it. Okay, then only you will get better understanding. Okay. So in our case, we have so many solar panels. This is only a small portion. Okay, in the GDN building itself, more than 350 to 500 panels are there. Make is Tata make panel. Each panel 200 watt peak like that. So this is the inverter for it. Can you read the instantaneous power generated? It will give instantaneous power generated. This is its connection, wiring connection. Okay. So we will have in next unit more about solar PV. We will get some more details about it. Okay, what is the power generated, etc. I am giving this only to show that how it is used in our campus. So next one is would like everybody to form a topic for your J component. This is a J component subject, right? So as a part of your theory study, you are supposed to take up a small project. That is called J component project. So related to our topic, okay, solar energy or energy consumption reduction through PV system. It need not be strictly on PV system. Maybe some deviations can also be there, but related to energy saving, you can or green energy utilization, you can have a topic. So it can be a design project, fabrication project, or a case study. Design means you can design solar PV system for an application. If you are interested very much, you can have a small fabrication of the item, prototype, something like that. Otherwise, a better and impactful case study, not a small one. Okay, a big case study also you can present. Is it clear?
Sir, how
yes.
to design solar panel? I mean, we need to build it, sir.
Design solar panel is not required. We are not supposed to design a solar panel. Panels are available, no, commercially. Design a project means, suppose you want a charging station for a two-wheeler. Suppose nowadays two-wheelers are coming up very big, no, electric. So if you want to have a charging station using solar PV, how much number of panels you can use, how much a calculation, how much scooters can be charged in a day. If you are using battery, what is the battery storage needed, all these things. That is the design of the solar PV. Panel design is not recommended. Panels you can use any. Suppose you take 100-watt peak panel, you will get some value of number of panels required. 200-watt peak panel, another number. Okay. Otherwise, I will show you a case study. Suppose I have shared in our group Teams. Have you gone through it? Today morning I have shared a paper, journal paper. Have you seen?
Sir, where, sir? WhatsApp or Teams?
Not WhatsApp. Our team, our class team. This solar PV team is there, no?
Yes, sir. So we haven't seen it, sir.
Have not yet seen. You go in the chat section, it will be there. For you, I will be showing now. This is a paper recently published by our VAT faculty regarding estimation of solar potential for charging in Indian scenario. Okay. Okay. Is it coming to your screen?
Yes, sir.
Yes, sir.
So this is a journal paper, design and analysis of solar powered electric vehicle charging station for Indian cities. Okay. So some of the others are from VAT. So what they have done, what is a necessity? Okay, that is the introduction and abstract. So what is their objective? They have used a software called PV-Syst for simulating the system. What is the system? Charging system. So based upon standards, EV charging standards, charging time level, all these things they have considered. Fast charging. This data you will get from internet also if you search. Okay, Bharat DC, some standards are there. Nowadays, government is also promoting EV, electric vehicle. So some standards are being set up according to that standards and getting some selected locations: Ladakh, Delhi, Chennai, Tawang, Bangalore, etc. Like that. Different climatic zone, some selected cities they have taken. Their climatic conditions and global radiation, kilowatt hour per meter square zone. These data, weather data are available in some standard websites as well as some references you can take. This they have references 26, 27. Okay, you are already given this data. So PV sizing, their PV sizing, they have used that software, no? So like this, a charging station. We don't know presently what is if you use this much panels under these climatic conditions of different cities, how much energy it will produce, and with that energy how much cars or vehicles can be charged. We don't know exactly the answer. So using a simulation study, they have made the answer to it. Okay, that is the meaning of a case study, or you can read and explain this paper. That is a case study. You are supposed to cover all these topics, all these details, and also the result. Result they presented is using these equations for designing the PV system, and inputting into the software, they got so many results. Ladakh performance ratio. So what is performance ratio? Define it. They got different locality, different performance ratio. Then annual unused energy for different array. So what is unused energy, and different locality, different value. So all these things you can study the paper and explain in a simple manner. That is the case study presentation. Right. Site station structure, PV array orientation. Battery. What type of battery? Autonomy means how much freedom. Suppose once charged, will it last 2 days? Means 2 days autonomy. Like that. 1 day means 1 day autonomy. So this is the one example I am saying. Like that, many examples you can take. Different types of solar panel. What is effect? Polycrystalline, monocrystalline.
Sir, so how long can we make the, or sir, what is the minimum limit for the case study? Sir?
How long means time duration you are asking, or the complexity of the study? Complexity, right?
So, yes, yes, sir.
One case study can be of this paper length, or an actual solar power plant, full details. Solar power PV plants are installed in many states now. So how much, what is its energy production characteristics or statistics? What is the make, how it is made, installation procedure adopted, safety standards are adopted, how much electricity is produced, and what is the rate at which it is sold. So it can be a 25 slide presentation. For the your presentation means first presentation is topic selection. You have 3 review presentations for J component. So first one, we are respecting the topic. Second one means there's some background and a literature study. The final review means your exact work. Okay. So for the last one, you can expect some 20 to 30 slides presentation with all the details that I am expecting for a case study. Need not be a case study. You can purchase a panel, do some experimentation and report for a small purpose. Okay. That is also a fabrication type. Another one is you can design using some software. You can design. Okay, these people in this paper have designed a charging station. Like that, for a small electric scooter charging station, what is the results you can get? If you for a selected building for powering the fan and light loads, if you design using your software, what is the result? That also you can present. Or even what is the trend in solar PV industry? A literature study you can present. How to manufacture? What is the recent research taking place in the area? You can have a literature study and present. So many you can think of. Okay. You read the internet materials. We have the MNRE case studies can be obtained from MNRE website. Akshaya Urja, one magazine is there. Otherwise, so many blogs will be there. Company blogs, their case studies you can get. Nowadays, PV utilization is on the rise, right? 26%, I think, from renewables now, total primary energy consumption. Earlier it was 3%, 4% like that. Now it is increased. Share is increased. So many installations are there. You can take case studies. So I find the first DC assignment you have done very simple. But these things you have to take your effort more. Okay, simply some ready-made item, just pasting in the PDF and sending to PDF is not expected. You have to make a reading references, make your own some contributions, conclusion, etc. That means more involvement is required if it is a case studies presentation. Otherwise you have to design yourself using some softwares, or no, need not be software also, hand calculation also need. You can use equations and calculate. Only thing is you involve yourself in this study.
Sir, how
So
many
this
members
is
in a group?
Pardon?
Sir, how many members in a group?
Maximum 5. Okay. If you are interested, you can do alone also, yourself. But if you are interested to do in a group, it can be 2, 3. Maximum 2, 3, and maximum 5. Beyond that is not expected. Okay.
Thank you, sir.
So where is our WhatsApp group? How can I join WhatsApp group? Is it formed or it is still in making?
Sir, yesterday I sent the link, right? Just click on
Where it is a link? Where is the link? Has everybody got the link?
Yes, sir.
So where is the link? How can I join?
Sir, in chat box.
Now in chat box it is there. Okay, okay. So everybody join this group. Our further communication we can make this WhatsApp group. Okay. For quick conversations. Okay. Any sudden announcements, etc. This other modes it will take time. If it is WhatsApp, you will be having your phone always with you. You will be also noticing it. Otherwise, you will miss it. Jatin, this is the link, no? Jatin only sent the link, no? Chat.whatsapp.com. Okay.
Yes, sir.
Okay.
Oh, sir.
Yeah.
Sir, for project we have to create a group, right, sir? Like 2 members, 3 members, 5 members, or not?
Pardon?
So, like for J component project, like case study, we have to create group or not?
You have to make a group. Group making is needed. Not needed. If you wish to have form group, you can make. So
It is not compulsory, right, sir?
not compulsory. If you want to do alone a J component project, you can do it. But if you want to do it in a group, similar people can come together and form a group. The topic can be fixed, and so this through this WhatsApp group you can interact among yourself, and if you need any group formation, you can make a group. Okay, our first review will be towards next month, first week. Okay, that means September first week we can expect first review. Before that you make a group. So this link I should type in the WhatsApp, right?
No, sir, just tap on it.
Just
Tap on it, sir. With your phone, tap on it.
Tap. That means take scanning.
No, sir. Just click on it, sir. Just click on it.
Then we can enter our mobile number and join, right?
Yes, sir.
Okay, it is coming with some Tamil WhatsApp. Tamil is the medium.
Sir, wait, sir. I'm
Okay,
adding.
okay, you can add. Otherwise, you can add. I will share my number. You can add.
Yes, sir.
Have you added me?
Sir, like your number is 784537 like this, right, sir?
784.
78457568
Yes, yes.
Okay, sir. Wait, sir.
No, no, that number I don't have WhatsApp. Geo number, another one is there.
So, sir, please put in chat box.
Okay, okay. So today we will wind up with the first unit. What is the first unit? Solar radiation and its measurement estimation. Next class onwards, we will go with the second unit, that is basics of solar PV. So
Yes, sir.
can anybody summarize what we have discussed in the first unit? I would like somebody to summarize the major topics that we have discussed. Nobody willing. That means nobody understood.
Regarding solar radiation, sun-earth angles, latitude angle, longitude angle, zenith angle, azimuth angle, and regarding the calculation of daily solar, global solar radiation, and different instrument used for calculating solar radiation, like pyrometer, pyrometer, and
Pyronometer, pyrheliometer, shaded ring pyronometer.
yes.
Okay. Any other topic? Estimation, Page Angstrom method, right?
Yes, sir.
So I hope you are maintaining your notebook. If you not yet started, start immediately and make your own note. Okay, it is very much essential for your exams. So I will make the summary for everybody. So first unit was about solar radiation. So it started with the basics of energy. What is the energy? We have started at defining energy and its types. We have energy, the ability to do work as the basic terminal. So it will come in various forms. So various sources are conventional and now new sources. Conventional means our non-renewable. That means fossil-based energy sources like coal, crude oil, diesel, based like diesel, petrol, kerosene, all these things. Then natural gas. So this is presently also a major share in the world consumption data, fossil fuels, because it is density is very high. That means concentrated form of energy. And all our energy conversion systems are developed over it. IC engines, power plants, all these things. People have developed based around these fuels. So now it is posing challenge in the form of global climatic change, and the trend is using more renewable energy sources. So renewable energy means it has got many demerits. It is diffuse in nature. That means per area we will get only few. So solar itself, in a meter square we can expect 300 watt, 400 watt or 700 watt, less than 1000 watt. Wind also similarly, density is very less. So but anyway we will have to use maximum its share increase. So we are having power plants and some applications using this renewable energy. And our subject matter is solar PV technology. So we need to have understand what is solar radiation before going to PV technology. So solar radiation is electromagnetic radiation. It comes in various spectrum of wavelength. So we have ultraviolet, visible and infrared, that wavelength and energy content variation we have studied. Then solar radiation, a small fraction of sun's solar radiation only get on Earth. That too on the surface it varies due to various mechanisms on the coming. That means diffraction, reflection, interference, absorption, etc. in the atmosphere. So we can expect almost constant radiation in a day over the beyond atmosphere region, that is called extraterrestrial radiation. That is 1.36 kilowatt per meter square. That also varies according to day. So some correction equation is there. It is given in the data book. So we have then studied the Earth Sun geometry, because if you want to estimate solar radiation on Earth, we want some equations. So these equations use the geometry of Earth and Sun. So we have accordingly defined so many angles: inclination, latitude, longitude, hour angle, azimuth angle, all these things. So that is given in your data book, that relations. You need not by heart it. Its terminology is explained in the PDF that is shared. So you have to read some 3-4 times before it is very by heart, not by heart, very very much clear to you. Okay, this what is these things. So you read the, I recommend everybody to read the PDF. So once the angles are determined, we have discussed Page-Angstrom method to determine solar radiation. So Page-Angstrom method only a rough estimation. Global radiation we can get in kilojoule per meter square a day using locality, that is A and B constants, and also amount of extraterrestrial radiation H0 calculated by some other equation, and in terms of sun length, sun hour length. That means in a day how much sunshine is there. So sunshine average you will be given, maximum you can calculate based on sunset hour angle, omega s. S mass is equal to 2 by 15 omega s. So in the equation of H0, one thing is you have to put omega s in radian. That today we found. Okay, otherwise you will get a negative value. So one typical numerical you can expect with some locality only changed. Okay, locality and day changed. So procedure is same. So you can practice this numerical. So once numerical is done, we have today discussed the instruments: pyranometer, pyrheliometer, and shaded ring pyranometer for measuring solar radiation. So everything works on thermopile sensor. It will generate EMF, small EMF in the range of 0 to 10 millivolt, that you can calibrate taking sensitivity of the instrument into watt per meter square. So this is the usual sensor. Okay, thermopile. We want the voltage only, so we can use another sensor. Even the photovoltaic cell also we can use, but it has got some demerits. It won't capture all the spectrum of solar radiation. So people are not preferring solar cell, but this thermopile, thermocouple people are using widely. So with this we have concluded the first unit, and we have asked you to form topic. Okay, it can be individual or team based project, J component project topic. So we will wind today. Pardon.
Sir,
Mm-mm.
so that so when will be the first review of the case study?
That I told. First review is next month, first week. I will tell the exact date. Tentatively between 2 and 4. Between we have class on 2. No, 2 we have class. Sorry, 1 we have class. So it will be 3. Okay, maximum 3. 3rd of September we can expect.
Okay, sir.
Sir, in that we have to just give the group and the topic name, na?
Yeah. First review expectation is what is the group and what is the this topic. Okay, how you are going to do. Meeting attendance list. So now you can leave. Okay. So now you can leave. Okay. Any doubt till our discussion? Yelena Parjuli, your doubt is cleared or not?
Yes, sir.
Okay. So you can leave. Okay. Thank you.
Yes, sir. Thank you, sir.
Okay.
Thank you, sir.
Thank you.
Thank you, sir.